Hi everyone, welcome to 7-5 Geometric Sequences Applications. And when we talk about applications, we're just simply going to be looking at word problems. So the learning target for today's lesson is I can apply my knowledge of geometric sequences by answering a word problem. So all we're doing today is we're going to be looking at one model problem about a bouncing ball that's dropped from a height of 8 feet. So remember, whenever you were dealing with a geometric sequence, the formula is a sub n equals a sub 1 times r to the n minus 1 power. So I would like you to pause the video, rewind it a little, so you can hear me say that formula one more time. And then I would like you to say it at least once. That way you're getting used to the language. Some key words that we're going to be looking at, here are some of the giveaways that it's going to be a geometric sequence word problem. Multiply, growth, decay, percentages, such as 80%, 50%, 60%, any number with a percentage. Doubling and tripling. So whenever we're dealing with geometric sequences, the numbers are getting very, very large or they're getting very, very small. This is similar to what we learned in our last unit where we learned about exponentials. And that's because geometric sequences are just exponential functions. So that is something that we need to remember as we progress through this unit. The geometric sequences are just exponential functions. Arithmetic sequences are linear functions. Remember, it's all about those constant rates and those words that we look through our word problems. So let's attempt a model problem. Here's where I would ask someone to read it during class, but I'll do. We have a ball that's dropped from a height of 8 feet. The ball bounces to 80% of its previous height with each bounce. How high, to the nearest tenth of a foot, does the ball bounce on the fifth bounce? So the first thing we're going to do is we're going to read the problem one more time. A ball is dropped from a height of 8 feet, and the ball bounces to 80% of its previous height with each bounce. How high, to the nearest tenth of a foot, does the ball bounce on the fifth bounce? So the first thing we do whenever we have word problems is we need to come up with the explicit formula. The explicit formula was the formula on the top of your page. I'll rewrite it down here. It is a sub n equals a sub 1 times r to the n minus 1. What's nice about word problems is that you actually don't have to write out the sequence. If you are able to decode it and decipher it and figure out what's my a sub 1, what's my rate, what's my common ratio, that's what I mean, then you can actually just go ahead and substitute. The question says that the ball is dropped from a height of 8 feet. That is your a sub 1. So when I rewrite my formula, I'm going to do a sub n equals 8 parenthesis. I don't know what my r is yet. We'll do that next. And I'm going to raise it to the n minus 1. Here's what we do know. We know that we're going down by 80% each time. So it bounces to 80% of its previous height. Here's the issue. Our calculator doesn't have a percentage key, which means our common ratio isn't 80%. It's actually 0.80. This is my explicit formula. But here's the issue. I don't really care about my explicit formula. The question isn't asking me to find my explicit formula. However, I need to use my explicit formula to find out how high the ball is on the fifth bounce. Which means that I simply want to find a sub 5. So I plug in a 5 for n. And this is all calculator work at this point. You need to type this into a calculator. Again, if you don't have a calculator at home, go to Desmos.com. You can type this into Desmos and you can get an answer. I'm typing, don't worry. After typing this into my handy dandy TI-84 Plus Silver Edition, I end up getting, as my final answer, 3.2768. If you look at the question one more time, it says round to the nearest tenth of a foot. So, I only want to go out one decimal place. I look at the number next to it. 7 is higher than 5, so I go to the sky, which means I round my answer to 3.3. That is how high the ball will be after 5 bounces. Now what I'm going to ask you to do is watch this video one more time if you're still stuck. If you're not stuck, go on to the independent practice. But please, please, please make sure that you remember to leave one question that you have on the discussion board on the Google Classroom. If you have any questions, as always, please just reach out by email or private message me on the Google Classroom. Ladies, again, have a nice day.